Hello everyone, my name is Abhishek and welcome back to my channel. Today is day 7 of AWS Zero to Hero series, and in this video I'll show you how to implement a real-time production grade AWS project. I'm also very excited about today's project because we will see how to use all the concepts that we have learned till today. That means from day 0 to day 6, right from EC2 instances, VPC, public subnet, private subnet, security groups, load balancer, everything. So this is going to be really exciting. Please watch this video till the end so that you can also implement this entire setup after the video. Before going into the video, just to let you know, this is also the most recommended approach by AWS if you want to deploy your applications securely in a EC2 instance. So I'll also share the AWS references, blogs about this architecture, but after the video, you can check them from the description. So firstly, let me give you a brief overview and what is this project about? What are we going to implement? What are some things that we need to understand before the implementation of the project? Firstly, this project demonstrates how to create VPC and how to secure your applications within a VPC in a production environment, right? So if you look at the architecture diagram here, there is a VPC and inside the private subnet, we have deployed the applications. And there is a public subnet where you have load balancer and the NAT gateway. Users would access this application through the internet gateway to the load balancer, and from the load balancer, it will reach the applications in the private subnet, right? So this is the entire architecture that even I am trying to explain here. So you can pause the video here and you can also just read through this entire thing so that you can explain this same thing when interviewers ask you in the interview process. But just an overview, like in 4 lines. First, we will create a VPC that has public subnets as well as private subnets in 2 availability zones. Now, why I need 2 availability zones? You can ask me like, Abhishek, when you explain the theory part, you were just using one VPC. In that VPC, you are only using one public subnet and one private subnet, and that too in one single availability zone. But when you do this in production, just you need to create 2 availability zones instead of one, so that for some reason, if the data center of AWS in a specific region or the availability zone of AWS in a specific region goes down, you will still have the other availability zone that is serving the traffic for you. So that's the only purpose. We create a VPC with public subnet and private subnet in 2 availability zones. And in the public subnet, what we will do is we'll deploy a NAT gateway and a load balancer. Why you need load balancer? I'll explain you. But why you need a NAT gateway? Let's say this applications here, if they want to access something from the internet, probably they want to get some JSON information, or they want to get some kind of information from other APIs in the internet. So it is better to mask the IP address of these applications when they send a request. So that's exactly what NAT gateway does. So let's say the IP address of this one is 172.16.1.0 or 172.16.3.4. When the application or when the EC2 instance tries to access something from internet, what this NAT gateway says is, okay, let me change your IP address to the public IP address of mine and send the request so that your information will be hidden. Even if the third party application is a false application, or even if it is hacked, there will not be any problem because you don't know. I mean, that person does not know the IP address of this server. That is about the public subnet. And in the private subnet, you will launch these applications using an auto scaling group. Okay, what is auto scaling group? I'll just explain you in a minute. Finally, we will see how to reach this application through the internet, how traffic flows, and we will also, I'll also tell you how these applications access internet using the NAT gateway. So this is going to be the complete overview. And before I jump onto the video, you should know about these 4 things, because I covered these things in the day 0 to day 6, but I did not cover them to an extent that it is registered for everyone. Bastion is something that I did not cover at all, but the other 3 things I covered, but not to the fullest. So let me give you an overview. Auto scaling group, load balancer, they have dedicated sessions in this AWS Zero to Hero series. But in this project, I'll use them so that you should understand the summary of it. Firstly, what is an auto scaling group? So auto scaling group is, you can just understand it as a concept. Let's say you want to deploy your application in two availability zones. Instead of creating your EC2 instance two times, what you can do is you can just tell the auto scaling group that, okay, so create minimum of two replicas, and in case my application receives more requests, and if two servers are not enough to load this two servers are not enough to accept the traffic, incoming traffic. Let's say two servers can only accept 100 requests, but there are 200 requests that are coming at you. What auto scaling group can do is it immediately can take a decision and scale your servers to 4 in number, 5 in number, 6 in number, right? So this is a very basic example of auto scaling group. In future we will discuss about auto scaling group in detail, so don't worry about it for now. Then you have load balancer. What is load balancer? The name itself says what is load balancer. It is something that balances the load. Let's say there are 100 requests. Now we have two servers, right? There is server 1 here and there is server 2 here hosting the same application. So load balancer takes the responsibility of sending 50 requests here and 50 requests here. Or if you have this instance very powerful, right? So you can say send 60 requests here, 40 requests here, 80 here, 20 here, and load balancer will exactly balance the load, right? Apart from that, using load balancer, you can also do path-based routing, host-based routing, different kinds of routing mechanisms, which we'll cover in depth when we come to the load balancer topic in the AWS Zero to Hero series. And one final topic is what is Bastion or a jump server. This is a very, very simple concept. So these EC2 instances, right, that we are created in a private subnet. So they don't have a public IP address, or we cannot SSH into these instances directly. So what we will do is, because we want to keep them secure, we will not create any IP addresses, public IP address for them, but we will create a Bastion host or just a jump host in this public subnet, and through that Bastion or jump host we will connect to this EC2 instance. And there are multiple advantages of using Bastion host. The one mechanism is the same thing that I've just told you. If you use Bastion host, instead of directly connecting to this server, you can connect from the Bastion, so that there will be a proper logging mechanism. You can do proper auditing of who is accessing this private subnet. You can configure bunch of rules in that Bastion host where the traffic actually moves, or the SSH traffic actually goes to this application in the private subnet through the Bastion host, right? So we will discuss about advantages of Bastion host again, because this is not the topic where we want to discuss about Bastion, but this is a topic where we want to implement this entire architecture, right? So I think we have enough information. Now we can get started with the project, and let's see how to implement this end to end on an AWS account. Okay, so I have logged into my AWS console, and let's start with the creation of VPC. So go to the search bar, type VPC. So you will see an option for isolated cloud resources VPC. Click on that. So you'll find an option called create VPC. Click on create VPC, and there will be two options here. One is to create VPC only or create VPC and more. If you click on VPC only, then you have to create all the things by yourself. Like for example, you need to create all the subnet configuration, IPv4, IPv6, and a lot of other configuration. But the better thing is to go with VPC and more. So when you click on VPC and more, you will see in the preview diagram what AWS creates for you. So AWS creates a public private subnet in US East 1A availability zone, and it will also create a public subnet and private subnet in US East 1B as well. So if we go back to our diagram, which we have been talking about, right? So as I told you, you can search that in the AWS black blocks as well. Just search for AWS public private subnet architecture. So this is the blog that I was talking about, which I wanted to share in the description. This blog also has the information, but you don't have the complete details in this blog. Like they are very high level. Probably, someone might not be able to follow this and execute this. So I'll explain in much better way. So just use this diagram as reference, and we can implement that in our own style, the style that we have learned from day 0 to day 6. So see what we are trying to do here. When you click on VPC and more, what AWS is creating: one public subnet in US East 1A, one public subnet in US East 1B. which is what we want, right? One public subnet here, one public subnet here. And then you have one private subnet here in US East 1A and one private subnet in 1B. Exactly same, one private subnet here and one private subnet here. So VPC is getting created, subnets are getting created, and what all? So along with the subnets, of course, the subnets have to be attached with the route table. When I explained the VPC architecture, I told you route table is the one which defines how to route the traffic within the subnet. So if the subnet is not attached to route table, technically nothing happens with the subnet. So if you look at the public subnet, it is attached with a route table that has a destination as internet gateway. Awesome. That is exactly what we want. This public subnet should have a route table with internet gateway attached to it so that traffic flows into the public subnet. So that is also done by the VPC here. Great. And finally, you have two private subnets which have two different route tables expected because these two route tables are different, and it is attached to a VPC endpoint for S3 bucket. Now I don't want this one because this project has nothing to do with VPC endpoint. And when we talk about S3 buckets, you will understand about what exactly this is. For now, just ignore this, and I'll also remove this from the configuration. So okay, VPC and more is what I want. Then select the name of the project. Let me call this as AWS prod example. Use the same subnet. There is no problem here because in this VPC you have 65536 IPs, which is too much. So that's totally fine. I don't want to touch it. No IPv6. I don't want to play with IPv6. I'm just using IPv4 configuration. Number of availability zones. It is 2 that I require. Perfect. Number of public subnets 2. If I change this one, the reference diagram also gets changed. Number of private subnets 2. NAT gateways, yes, I want one NAT gateway in one particular availability zone. So let's say one per availability zone. And this is the VPC endpoint that I'm talking about. Just click on none. You will notice that this diagram also changed. And now there is no VPC endpoint for S3 bucket. Perfect. Now let's click on create VPC here and see that AWS creates bunch of resources for you. So take a pause here and read what all the resources that are getting created, because this is very, very important. Okay, maximum number of addresses have been reached, the elastic IP addresses. That's not a problem. Let me go back and see how do you delete that? You can just go to the EC2 console. This is again something useful information while you do demos. This is the advantage. So there is an issue here while I was creating the VPC. So the number of public elastic IP addresses is reached. So let me go here and release some elastic IP addresses. Okay. So these are some previous projects that I was doing. So let me release those IP addresses. If the IP address is released, then AWS will allocate this elastic IP address to the other things that I am using. So now if I go to the VPC console, let me click on retry here. So you will see at this point of time, the elastic IP addresses will also be created. What is elastic IP address? Elastic IP address in AWS is nothing but an IP address that will remain the same even if the instance is deleted. Let's say you terminate an EC2 instance. I'm just giving an example. If you assign EC2 instance with an elastic IP address, what will happen? Even if the EC2 instance goes down and comes back, the IP address will remain the same. In general, it does not remain the same. But if you're using elastic IP address, then the IP address will remain same. In very simple language, if I have to explain in a plain English, elastic IP address can be called as a static IP address because it never changes. Okay. So in this case, the elastic IP address, in my example, it will get attached to the NAT gateway because, like I explained you, what is NAT gateway? It will mask the IP address of my EC2 instance or the applications with the public IP address of the NAT gateway. So this is where the VPC is using the elastic IP address. Perfect. Let's see the VPC creation. So VPC creation takes a little time at this stage, creation of NAT gateway to activate. I mean, for the NAT gateway to activate, it will take a couple of minutes. So you need to wait patiently here for the NAT gateways to be activated. So now all of this is created, but even then you need to wait for a couple of minutes sometimes Okay, so sometimes your VPC is created, but sometimes AWS takes 1 or 2 minutes to reflect this in the VPCs tab. So if in case when you are performing the demo, when you click on these VPCs and you see that the VPC is not visible here or it is taking time, please be patient. Sometimes it takes time. Okay, now the VPC is created. Let's go to the VPC and see if the resource architecture that we have created till now. Okay, till now, whatever we have created is available or not. Okay, till now, what we have created, we created a VPC with public subnets, private subnets, public subnets attached to the route table and the internet gateway. And the private subnet is attached to different route tables. Perfect. Everything is looking fine till now. Now, what are the other things needed? So the other things that are needed is the EC2 instances where your applications are deployed. We will do them with auto scaling group as I've mentioned, and the load balancer is also missing. Now, once these things are deployed, we will try the traffic from outside, but there is a thing that you need to do additionally. We'll get there. So please watch it carefully. Okay. Now let's go to the console again and create the auto scaling group. So search for EC2. In the EC2, you can go for auto scaling option. Just scroll down, you will see this option called auto scaling groups. Click on create auto scaling group. Auto scaling group in AWS cannot be created directly. You can use launch template. So why you need launch template? Because you can use this launch template across multiple auto scaling groups, or this template acts as a reference. Like tomorrow, if you want to understand how your auto scaling group is behaving, is your auto scaling group scaling one instance, 10 instances, 100 instances, you can use this launch template as reference. So let me click on this launch template. Firstly, create that. Launch template will not have much configuration. You just have to mention what is the name of this launch template. Let me just call this name as the name of the launch template as AWS prod example. Let me give the same. And what will be the name? What are you trying to do here? Basically, deploying, okay, verification or proof of concept for AWS private subnet for app deploy in AWS private subnet. Perfect. Now it is asking what should be the operating system of your, or the, what should be the AMI, not operating system. What should be the AMI? Which image do you want to use? Ubuntu, CentOS. Let me just pick up what I've been using. That is the Ubuntu configuration. Click on the recently launched, and this is the Ubuntu configuration. If you want to browse more, you can click here. What should be your instance type? Always pick the free instances when you're doing this proof of concepts. Whenever it is required to use an additional configuration, I'll let you know. In the key value pair, pick up the key value pair that you want to use. Do not touch anything with respect to this specific option here, the subnet configuration. Let it be create a new subnet. Sorry, create a new security group. Okay, and provide the name of the security group. Again, let me give the same thing, AWS prod example. Just say allow SSH action. This is just a description. You can give anything. And here comes the important thing. In which VPC do you want to launch? I want to launch this auto scaling group, the instances in the VPC that I just created. And here you can add any inbound security group rules for the EC2 instances that are getting created. So my application that I'm going to deploy, I know that it is going to be deployed and accessed using port 8000. But what you can do is you can just open all of the things as well if you're not sure about your application configuration. But it is always suggested to keep the port that you are deploying, that your application requires. So what you can also do, like I'm saying, is just open all traffic. But if you open all traffic, then you are not following the security standards. So what I'll do is I'll open the ports that I require. One is the SSH port, that is port 22. That is the port 22. From which source? Anywhere. SSH port I want to access from anywhere. So this is one. And now add another security group for the application that is deployed inside these instances. So I'm going to deploy a Python application, very simple one. So I will open port 8000. So custom TCP port range 8000. In your case, you can change this according to the application that you want to deploy. And again, let me put accessible from anywhere. and I don't want to add any EBS volumes or any other configuration. So let me click on launch template. You must be feeling, Abhishek, this is exactly similar to EC2 instance configuration. Yes, it will be exactly same, because here you are using the auto scaling group to scale EC2 instances, right? So once you create that, just refresh the page so that auto scaling group will find the launch template. Auto scaling group name, again, let me say AWS example prod, or AWS prod example. What is the launch template? AWS prod example is a launch template. And now let me click on the next button. Here you need to choose the VPC. Okay, which VPC do you want to choose? You want to choose the VPC that you have created with, right? What is it saying? For more applications, you can use multiple availability zones. Okay, but in my case, I want to choose the VPC that I've just created. Availability zones and subnets, in which you want this EC2 instances to be available. Where these EC2 instances should be there? If you go to the diagram, they should be there in the private subnet. So let's put them in the private subnet. This is the private subnet, right? Private one. And this is the private subnet in US East B. So I'm choosing two private subnets. Perfect. Now all the things are available. Let me click on next. Do you want to attach a load balancer now, or do you want to attach a load balancer later? So I'll not attach any load balancer here. Let's just not go with any load balancer. I'll attach load balancer in a different context. I'll just create this load balancer. Okay, so I'll create an application load balancer in the public subnet, but in the auto scaling group configuration for this project, I'm not creating any load balancer. So okay, health checks, everything is good. Let's click on the next button. Desired capacity. Specify the size of auto scaling group by changing the desired capacity. Okay, so let's say you want two EC2 instances. Select this as 2. What is the minimum and how much it can go up to maximum? What is maximum? Like you are saying to start with two EC2 instances, but let's say during Christmas or during Diwali or some other festival occasions, if you receive lot of traffic, then auto scaling group, when the traffic goes to 80%, 90%, depending upon the CPU monitoring, what you can do with auto scaling is you can tell auto scaling to automatically go up to maximum capacity of 3 instances and 4 instances. So you don't have to worry about this right now. You will learn this when we go to the in-depth topic analysis of auto scaling groups. So you can configure the scaling options here. That's what I was talking about. Like when do you want to define when the EC2 instances have to scale up and scale down. So for now, just keep it none and click on the next button. Add notifications. You can add notifications through SNS topics when an EC2 instance is added or terminated. For now, I don't want any of those things. So let me click on next button and launch configuration. Perfect. Now my auto scaling group is also getting created. Again, this will take 1 minute. So just wait here before you move to the next. So after a minute, you will see that the desired capacity is 2 and the instances are 2. Now let's go to the AWS EC2 and see if this auto scaling group indeed has created 2 instances for us or not. And I'll also verify if one of the instance is created in US East 1A and the other instance is created in US East 1B or not. Okay, for that, let me go to EC2 here. Perfect. And click on the instances. Yes, there are 2 instances. Perfect. Click on one of the instance. Where is this created? See, this is created in US East 1A. Now let's click on the other instance. Go back here. Click on the other instance and see where is it created. See, this is created in US East 1B. Perfect. So you have this configuration also done. So auto scaling group is created, instance is created here and here. Now, before going to create the application load balancer, you have to do one thing, that is install the application inside these servers, right? I want to install applications inside this server. So now what I'll do for that is just go to those instances. So here comes one thing that you have to watch carefully, and this is very important. So let's go to the instance and try log into this instance. So you will notice that this instance does not have a public IP address. and that is expected, right? So I have not given any public IP address here because these instances have to be secure. Now you might ask me, but Abhishek, how do I log in into this? So that's where our bastion or the jump host comes to the picture. So as I explained in the theory part, what does a bastion or gem host does? So it acts as a mediator between your private subnet, and it acts as a mediator like between your private subnet and the external persons or the public subnet. So I'll create a bastion host here and access the private subnet from there. Okay. So what we will do is go back to the EC2 console, click on the instances and start creating a bastion host. Launch instance. So this is, I think all of us already know. Just call it as Bastion host and choose Ubuntu as the image. You can choose anything. Then choose T2 micro, provide key pair, AWS login. And what you will do here is make sure you add a security group which has access to SSH, right? So because you need to SSH to the EC2 instance, that is the Bastion host, and from there you have to SSH to this private subnets and install the application. So perfect, SSH is added. Sorry, where is it? Yeah, so SSH is already there, so I don't have any problem. Now there is one specific thing here called network settings. Edit and make sure this Bastion host is created in the same VPC. Okay, so if that is not in the same VPC, then it will not be able to access inside the VPC. So I changed that configuration and added it to the VPC. Perfect. Auto assign public IP address. Yes, enable. Without public IP address, it will not be of no use. Now just go and launch this instance. Okay, I will launch the instance, and once the instance is launched, what I'll do, I'll SSH to this particular instance. From there, I'll SSH to the private host. Okay, so what I'm doing for my personal laptop, I'll SSH to Bastion. From Bastion, I'll SSH to the private subnet. But to SSH to the private subnet, again, you want the key value pair, which is present on my laptop. So what I'll do firstly, I'll show you. Okay, so I'll copy my key value pair to the Bastion host as well. Why? Because if the Bastion host does not have the key value pair, let's say Bastion host is here, it does not have the key value pair. How can it log into the private host? Key value pair is in my personal instance. So I'll use a shell command called scp. Don't worry, I'll show you all of these things practically. So let me refresh the instances. Now you will see 3 instances. This is Bastion host, and these are instances in the private subnet. Perfect. So let me get my terminal. This is my terminal. And what I'll do is I know my SSH key is here. I've used an SSH key called AWS. So just search for grep AWS log. I think I've used this PEM file. So firstly, I want to copy the PEM file. Definitely I'll log into this Bastion host, but along with login to this Bastion host, I also need to log into these instances. For that, this Bastion host should have the SSH access for these instances, right? It should have the PEM file. So firstly, let's copy the PEM file. So open this instance, get the public IP address of this instance. Okay, now I'll use this command. I'll also try to paste this command in the description so that you can use. This is called as a SCP command, secure copy. So what I am securely copying, I am copying this specific thing called AWS login PEM, which is the PEM file for my private subnet instances as well, from my personal laptop to where am I copying it? I am copying, I'm copying it to the Ubuntu EC2 instance. Okay, so here I'm using the identity file, and then I want to copy this file to the instance. Okay, which instance is this? This should be my Bastion host instance. So let me change the IP address of it. It is very clear, right? What does SCP do? SCP securely copies file from one host machine to the different host machine. Now, from where I'm trying to copy? I'm trying to copy from my personal laptop to AWS EC2 instance, that is the Bastion host. So let's remove this IP address and copy the IP address of the Bastion host. So you will see what will happen. Let me just copy, say yes, and you will notice that the PEM file is copied to the Bastion host. Perfect. It is copied. Now let's go to the Bastion host and see if it is copied or not. How do I log into the Bastion host? Just copy this IP address again. Say SSH minus I, your key value pair PEM file location, Ubuntu @ this IP address. Just do ls, you will notice that the AWS PEM file is available here. If the PEM file is not available here, you will not be able to perform the next command, which is very, very important. That is, I will not be able to log into any of these instances. I need to log into one of these instances because I want to install the Python application in one of the instance first. Okay. So take the private IP address, SSH minus I, AWS PEM file, Ubuntu @private IP address. See, I am able to log into this specific instance with the private IP address 10.0.140.109. 10.0.140.109. Perfect. So that means now I am able to log into the private instance as well. I mean, what is a private instance? EC2 instance in the private subnet. Awesome. Now all that I'll do is install the Python application here. So very simple Python application. Let me do one thing. Let me create a HTML page as well. Index.html. So let's pick up a very simple HTML page. W3 schools, HTML basic. I'll pick up a very random example. Let's take this one, copy this entire thing and put this in my file so that I just want to host this file. Let me say that my first AWS project to demonstrate apps in private subnet. Okay, let me remove this. And now save this file and just run the Python server using Python 3 -m http.server on port 8000. Okay, let me run it on port 8000. So my application is running in one of the instance that is 10.0.140.109. So what I've done till now is I've used the auto scaling group. Perfect. Let's go back to the diagram. I've used the auto scaling group, created the EC2 instance, created a Bastion host, logged into only one of the instance. So see why I've logged into only one of the instance, because while using load balancer, I want to demonstrate that traffic is going to one particular instance. It is hitting and giving you back the response. Whereas when it goes to the other particular application in a different subnet, it is giving you an error response because this page is not available or the application is not available. Okay, so for that purpose, I have installed Python application in one EC2 instance and I did not install in other EC2 instance. So this is an effective way of explaining you the load balancing concept. Okay, we will see 50% of the traffic should go to one instance, you should get the response, and 50% of the times it should go to other and it should not get the traffic. Perfect. Now what I'll try to do is create the load balancer and attach these instances as target groups. That will be our final stage. So again, let's go here, search for load balancer or go to EC2. That's a easy way. And in the EC2, you have load balancers. So there are three different load balancers. Now you don't have to worry about it. What is application load balancer? What is network load balancer? Classic load balancer, gateway load balancer. We will come to that when we discuss about load balancer topic in detail. That will come after day 20 or something. So don't worry about it right now. Let's go with the default. That is the application load balancer. Not default, I mean. Let's go with this one. Click on the create button. And what is an application load balancer? On a high level, it does the HTTP and HTTPS, which is L7 load balancer, layer 7 load balancer. So provide the load balancer name. Let's call it as AWS prod example. The load balancer should always be internet facing. It should be in the public subnet, right? So we have discussed this multiple times. Load balancer should be in the public subnet and should have access directly from the internet gateway. IPv4 makes sense. What is the VPC that you want to provide? So you know what should be done. Provide the VPC that you have just created. In which of the availability zones? Just pick up both the availability zones, no problem. And it should be with the public subnet, right? So change to the public subnet. Even if you put that in a private subnet, AWS will give you an error. So put both the subnets, both the availability zones, and put the public subnet range. Now the security group, you can select any security group, does not matter, like, or you can create a new security group as well. What you are trying to do in a security group is, for the load balancer, are you allowing all the traffic or not? Or in the VPC where the load balancer is there, are you providing access? Where in the security group you can define, okay, open port 80, open port 8080, whatever it is. So whatever I have attached here is the default VPC. You can remove this one, the VPC for AWS prod example, and launch wizard. So if it does not work, what we can do is we can create another security group and we can attach that another security group here, so that what will happen is load balancer, which is listening on port 80, should be accessed from the internet. What is this security group doing? It is allowing SSH traffic and port 8000 traffic. What is this doing? I'm not sure. I need to look into this security group. So let me remove this as well. For now, just add this one. And if it does not work, I'll go to this security group and add port 80 as well. Listeners and routing. Okay. So you need to create a target group where you will define which instances should be accessible. So create a target group first. Just like launch template, firstly, we'll create a target group. And what is the target group? EC2 instances. So which EC2 instances do you want to access? Target group name, just provide AWS prod example. Perfect. And what you are trying to do is you are trying to use the HTTP protocol only to the instances. This is the VPC. Perfect. Health check, HTTP. Perfect. Move to the next tab. Select the instances. This is one instance and this is the other instance. One instance has the application, other instance does not have the application, but it is perfect for the demo. Later, you can also add the instance, add the application to that instance and see that the traffic is flowing. You can try different things. In one, you can say, hi, this is Abhishek. In one, you can say, hi, this is Veeramalla, and see how the load balancing is happening. Targets, perfect. Include as pending. Now create target group. Okay, so if you have noticed here, what I am trying to do is I have misconfigured. I said that the target group on port 80. So I need to just go back. There is no problem. Go back to your application and just change the port 80, right? So the application that is running, I can just simply go here and run the application on port 80. The reason is that I have misconfigured, or just keep it like this and create the target group. Just modify the target group. This is the one, right? So what you will do is go back to the target group, and here where you have option for targets, this is the port. I'm saying on port 80, but actually the port is 8080. So let me delete the target group, no problem, and recreate. Create target group instances. Let me do it very fast. Target group name AWS prod example. Just say port 8000 where I'm trying to access. HTTP1 VPC prod VPC. Health check is fine. These are the instances which I'm trying to access on port 8000. Perfect. Click on create target group. Oh, sorry. Just include as pending below and click on the create target group. Now the target group is getting created. So just wait for 1 minute here as well. And what is this target group doing? Basically, it has two EC2 instances, which it is verifying on port 8000. Now I'll just go back and add this target group to the load balancer. You might not find it at this point of time. Just wait for a minute or do the configuration one more time. Okay, go to the load balancers, create load balancer, go to application load balancer, create AWS prod example, internet facing, yes. Click on the VPC, prod example, both the subnets and both the subnets using the public thing, right? And then the security groups, like I told you, firstly, let me put one security group. If it does not work, I know what to do. Because I'm accessing the load balancer on port 80, I can simply open the port 80 in the security group because I'm accessing the load balancer on port 80. Prod example, perfect. Or I can access the load balancer on port 8000 because I know this particular security group is exposing port 8000. But okay, for the purpose of video, just to show you how this thing exactly work, I'll just use the port 80, which is default. Add-on services, load balancer tags. You have used the target group as well. Everything is looking fine. Create the load balancer. Load balancer is created. View the load balancer. It will take again a minute. So wait for a minute here for the load balancer to provision. And once the load balancer is provisioned, let's try to access it from the outside world. The expectation is when you access the load balancer from outside world, you should see that load balancer gives you a response of the application. So let's wait for a minute here. So now the load balancer is in active state, right? So all the configuration is created at this point of time. And what I've done intentionally, I did not create application in one of the servers, right? But all the other configuration is completely created. I have load balancer, internet gateway, public, private, all the things are available. Now, let me go back to the load balancer and try to access the load balancer. You will see that the load balancer is not accessible because the subnet that you have attached to the load balancer does not expose port 80. I've already told you. So let's see that in practice. So even if you go to the load balancer, you will notice an error. So just scroll down, you will see that, okay, it says that the port 80 is not reachable. Why? Just click on this. It will say security groups for your load balancer don't allow traffic on the listener port. So what you need to do is either go to the security group. So this is a security group, right? Click on the security group, open it, and allow the HTTP traffic on it. How do you do that? Just go to the inbound traffic rules, edit inbound traffic rule, add a new rule called HTTP, open port 80, perfect. Anywhere from the internet is fine. Save rules. After a while, once this configuration is reflected, you should see this error will disappear. What is this error? The listener, where you will see this should disappear. Okay, so it might take a minute. Perfect. Now it is reflected. Now let us access this particular IP address from the internet and see if I'm able to access the my first AWS project to demonstrate app in private subnet. Congratulations. You have implemented your first AWS project and you have demonstrated a very complicated project, the project that is used by most of the engineers as DevOps, I mean, most of the DevOps engineers in their organizations. We have implemented this entire concept. Again, like I told you, I have intentionally not deployed in one of the instances. So sometimes you will get an error. Okay. So if you see here carefully, what is happening is the page is not getting reflected. Let me do it in two different tabs. Okay. So, okay. The reason why it is going is there is a target group here which is actively monitoring the healthy parts. So for example, this is a target group, right? So what is happening here? This target group, which I've created, has a health check. Okay, and it is only forwarding the traffic to the healthiest EC2 instance. So one is healthy and one is unhealthy. So what is happening is the load is always going to the healthiest EC2 instance. Okay, so in future videos, I'll show you, don't worry, where I will configure this health check in a way where it should send irrespective of the health check. Like, you know, you can disable this health check and send that send traffic to the both EC2 instances. But for now, perfect. You don't have to bother about it. The project is demonstrated. And what you can do to see the load balancing concept is go to the other EC2 instance right? So we have created two EC2 instances, right? In one of the EC2 instance, I created Python application saying this is my first AWS project. Go to the other EC2 instance in the same way that I've explained and call this as this is my second AWS project. Okay. Deploy the application, deploy the HTML page with my second AWS project. And now when you hit the load balancer, once you should see my first AWS project, and second time when you hit, you should see my second AWS project. Okay. Because that time both your EC2 instances will be in a healthy state, and target groups will forward one request to one EC2 instance, other request to other EC2 instance. So this is your assignment. Try to do it and let me know in the comment section if you were able to perform the assignment or not. Thank you so much. We'll meet in one more interesting episode of AWS in episode 8. Thank you so much. See you all. Take care. Bye.